this is designed to introduce the next speaker. What I love about Aruba and about TEDx Aruba is this nice mix of humility and also pride. I mean, the team of TEDx Aruba said we want to be humble, we want to invite speakers to our island to share their thoughts about sustainable solutions, but at the same time we are very proud of some of our local heroes. Now, the next speaker is certainly on that last list, and because he's extra special, he is a sir, we created a special video to introduce him, and this introduction will be done by a friend of the island, Dutch astronaut André Kuipers. Let's play this video to introduce the next speaker.
I'm André Kuipers, a European astronaut from the Netherlands and chairman of the advisory board for TEDx Aruba. And I'm very happy to introduce my colleague, Edward Cheung, the principal engineer at NASA. And Edward is the son of Aruba. He was born here. And because of his outgoing attitude, he is a big example and inspiration for young people. Edward worked on several subsystems of the Hubble Space Telescope, the famous telescope with which we discovered so much of the universe, and which just celebrated its 25th anniversary. He also worked on building the International Space Station, the place I called home for more than 200 days. Astronauts cannot do their work without the work of all these passionate and knowledgeable people. We astronauts often say we're standing on the shoulders of giants, and Edward is one of these giants. And he likes to share all his insights that he gathered during all his work over the years. Ladies and gentlemen, I'm very pleased to introduce to you Edward Cheung.
There he is.
Hi. Thank you, thank you. So let's talk sustainability tonight. As we saw in the intro, I work at NASA now, but I had the good fortune of being born on this island. My family and I made St. Nicholas our home. My dad had a small store in St. Nicholas there. And I grew up as part of 9 cousins in 3 families. And here you see a photo of all of us by the Queen Wilhelmina statue right a few kilometers out of here. So even though I work far away from Aruba, the island is never far from my mind. As you see here, this was shot during our week-long mission in zero gravity, and I wear the flag of Aruba proudly on my chest. Thank you, thank you. But for the past 20 years, my activity has mainly been on the Hubble Space Telescope, as you heard Andre say. And I've had the privilege of working on many of the new cameras and computers that we have built and installed over the years. And one of these items, I had the privilege of designing and naming the Aruba box, and you see it here. During its installation, the name of our island was spoken out in space, and of course the name of our country then went around the world and around the universe. I'm especially proud of that. So the Aruba box has a permanent place in the observatory now. It's on the outside, shown as a black arrow. It performs an important function to protect the Hubble Space Telescope. With all these upgrades, the Hubble is now our premier telescope in the sky. And that is an important function that NASA does. But we have a second, also very important function, and that's more relevant to our TED conference this time, and that's sustainability. How so? Well, NASA has a fleet of satellites in space, names like Landsat, TRIM, Calypso. We all use these satellites to look downward and see what is happening with our Earth. And what are we seeing? We're seeing that the level of carbon dioxide is very high now. Using ice core data for the historic ones and satellite data for the actual ones today, we see that historically we've had about 200 parts per million maximum in CO2, but nowadays it's hitting in the 400. So it's very high. And as we all know, CO2 and methane are good at trapping heat. And this heat is evident also in global temperature data. When you see averages on a global level, you can tell that the warmest 10 years have occurred in the past 12. And this despite the fact that we had a very light solar minimum in the 2000s. So all this is not due to the sun. So what is all this heat doing for us? Well, as you can imagine, it is melting the Earth's ice sheets. Everywhere, such as Greenland, and the Arctic, and the Antarctic, ice is decreasing on a year-by-year basis. So where is this ice going? It is going into the liquid ocean, as you can imagine, and causing it to rise. But there's a secondary effect, and that's the warming of the ocean itself causes it to expand a little bit. So the combined effect, we can see here on this graph, we've had about 64 millimeters of ocean rise over the past few decades, a slope of about 3.2 millimeters per year. So small places like us that are by the sea are very influenced by this, as you can imagine. So I could go on with other statistics like forest cover, ocean salinity, ocean acidity, but I think the basic message here, we have to become sustainable, we have to go renewable, and the best way to do it is by not using so much fossil fuels. Now, NASA is the US leading civilian agency on avionics research, as aviation research. And we want to contribute to using fuel in a sustainable way. And one way is we do a lot of research in aviation, such as the Helios prototype you see here. This research test bed has solar cells and batteries and is setting distance and duration records. It is able to fly continuously thanks to these batteries. We also have another test bed called the Leap Tech. It is used for testing out new types of propellers and motors. Finally, a large part of fuel consumption is commercial aviation, and we have the Eco Demonstrator. It is a Boeing 757 that tries out all kinds of ideas in order to make airliners more efficient. But we're not limiting ourselves just to aviation. A very large part of our technology can be spun off and benefit us in terrestrial applications. And one of the famous ones is solar panels, photovoltaic. These were the only option when we had to have the early manned missions, and that is to use energy from the sun. And now they have spun off, and we have developed triple junction cells and quad junction cells, and they are now used commonly in terrestrial applications, such as at our solar park at the airport. Another spin-off application has been in the area of aviation, taking that research and turning into improved wind turbines. And in addition, NASA's goal of supporting astronauts for long-duration flights has spun into using algae for biofuel or food. This and other technologies like batteries and fuel cells have all started in the space industry and now have application on terrestrial applications. But NASA's push for sustainability doesn't end there even. We operate our centers on a sustainable fashion also. For example, at my home center, Goddard Space Flight Center in Maryland, USA, we take gas from a landfill, siphon that off, and substitute that for propane, instead of propane, to run our center. Since 2012, we have saved $18.8 million doing that, including, not even mentioning, all the carbon we're no longer using. Another thing that's neat about my center is the bicycles. We have a lot of community bicycles available for anyone to use, and that's really nice because when you have a meeting at another building, you jump into these bicycles, you use them, and you ride them over. So it prevents you from having to, get your car and use the carbon that way. Another benefit is great exercise, and we also get to see our coworkers, and it leads to better cooperation. This is one of the things I'm most excited about, this kind of thing where it wins for everybody. And another way that helps the way NASA is going sustainable is by deciding that since 2006, that all our buildings are going to be LEEDs Silver certified or better. And indeed, we've been able to achieve more than gold and platinum certification in half the office space. An example of that is this one at Kennedy Space Center. It is LEEDs Gold certified with its integral photovoltaic roof and its built-in car charging station. It is NASA's first carbon neutral facility. Another one is this one called Sustainability Base over at NASA Ames in California, named after the well-known Tranquility Base exploration site on the moon. It is LEED Platinum certified. It has earned this because of the way it's managed its building materials, the rainfall for irrigation, and the way the inhabitants have access to energy. So all these are important ways that NASA has shown to be sustainable. But I want to mention that this is not something new to NASA. Sustainability really is at the core of NASA's culture. If you go back into many years, such as in the 70s, for example, we see many missions that are run this way. For example, Skylab. Skylab was launched in 1973, and initially its sun shield did not work. It was broken, causing the orbiting laboratory to be too hot and unusable. So instead of discarding this Skylab, we launched a repair kit with the astronauts. They were able to fix the sunshade with this makeshift repair, and Skylab was able to be used for years after that. Another example, and more typical example, is like of Star 6. When it was launched, its rocket motor didn't work. That put it in the correct orbit, and it was left in an incorrect and useless orbit. After that, the astronauts flew up with the shuttle, retrieved it, and we refurbished it and relaunched it, and Star 6 had a successful mission after all. Finally, the one in this picture is another mission that also had a upper stage motor that didn't work. The astronauts retrieved it and then put out this humorous sign, for sale. Who wants to buy a used satellite? So someone actually bought it, and we refurbished it, and it had a useful mission and was renamed Palapa B2 after that. So now we get to the point of the talk where I'm most familiar with, and that's Hubble. And I think there is no better program that shows how we are sustainable. We have visited Hubble 5 times, repairing it by changing instruments, computers, solar arrays, etc. And every time leaving the telescope, more than 10 times improved. Now, we could have done it by building a new one every time, of course, Hubble 2, Hubble 3, but that's, looking back, absurd. So we have always repaired the same one, which is a much more sustainable way to do it. And now, of course, Hubble is our premier telescope in space, always able to teach us more about the origins of our universe. So now that the shuttle has retired, our group now that used to service Hubble has transitioned into building hardware for space station, just like you saw Andre's intro say. And this is one of our latest hardware being installed onto the space station. You see the astronaut riding the big arm, the big SSRMS arm, holding this large washing machine-sized box, which is our equipment, our experiment being flown and installed in the space station where it's operating today. So I want to get to my last slide now, which is what we hope is the future of sustainable satellite industry. And that is where we repair satellites in space using robots. And that's what we do nowadays. We research that in our group. Our group is called the Satellite Servicing Capabilities Office at the Goddard Space Flight Center, where we aim to fly up with a satellite with robot arms. And we perform what we call the 5 Rs. And our first remote survey, where we fly around a client and see what kind of services they need. Then we do the second 2 Rs, replace and repair, similar to what we did with Hubble before, but now, of course, with robots and bringing on parts. The next R is refuel. Commonly, communication satellites only are used 5 to 10 years, and then they're discarded. Well, we want to refuel them, give them a new fuel load, and send them on their way for another successful 5 or 10 years. Finally, reposition. Just like Star 6 and Palapa B2, who were in useless orbits, we want to be able to reposition the satellites and put them in the correct spot. So I think I can say confidently that NASA really is a very sustainable agency. We not only show why we have to be sustainable, we also provide technologies to allow you to be sustainable and show the example by running centers in a sustainable way. And most of all, our missions have always been run that way. Thank you very much.
Wow. Thank you very much. This
Thank you.
Great talk and a great introduction by Andre. When you showed these pictures from your youth in San Nicolas, there was the audience went, oh, they thought it was really sweet. I understood that you have good memories also from this place, from Casticultura.
Actually, yes.
How come?
This is where I graduated from high school, from Colegio. I sat, third row in maybe over there,
Right,
in
yeah.
my white suit. And it was really nice. I haven't been back. I'm really pleased to be here and speaking to such a wonderful audience. And my sister used to dance on this stage.
Oh, wow.
And I understand her picture hangs somewhere in this complex. I would like to go
From
see
her
it.
as a ballerina?
Yes.
Okay, we
yes.
should find that. Okay, so, and you received your VWO diploma here?
That's right.
Okay,
from
so you
VWO.
a good education pays off. Yeah,
It was a tremendous education.
absolutely. Okay, Edward, thank you so much for all your work on the Space Telescope.
Thank you.
And being a true ambassador for
Thank you.
Aruba. Edward Cheung.